Okay, so when you study those three lessons or those 3 days of graphical transformation of functions, you're going to learn about translations, which is sometimes called shifting. You'll hear the word shifting. You also talk about reflection. So you can use a transformation called reflection. And then there's another one called stretching or shrinking. That's an R here, stretching or shrinking. And the word shrinking, sometimes some books will use the word compression. So if you see the word compression, it means the same thing as shrink. All right, so those are the three things that you're going to learn this week for Monday, Tuesday, and Wednesday on graphical transformation of functions. So the first thing I want to do is talk about translation. So this will be the first one. So part A will be translations. And with regard to translations, there's something called vertical translation, and there's something called horizontal translation. Okay, so vertical and horizontal. And and so that's that shifting that we mentioned here, the word shifting. So basically what's going to happen is that, and let me go ahead and put this back up here. Basically what's going to happen is that when you graph some of these functions, you're going to notice that, and here's the function absolute value of x. That's what the function looks like. So in terms of vertical translation, that's where you're going to move a basic function either up or down like this. And then horizontal is where you're going to go right or left. So that's horizontal translation, and this is vertical translation. All right, so vertical translation, and this is horizontal translation. Okay? All right, so that's what I mean by horizontal and vertical translations. Okay, so um, let's talk about vertical translation first. So let's do vertical translation. All right, a vertical translation is going to have this form where it's going to look like y equals some function. And notice that when I did this one, my function was the absolute value. Let me go ahead and put it here. My function was the absolute value of x. So some function, remember that's a function, it passes the vertical line test. For each x coordinate, there's only one y coordinate associated with it. So you have this function, and basically what's going to happen is that if this function's moving up, then you're adding some constant to it. If it moves down, then you're subtracting some constant from it. All right? So it's going to look like this. It's going to look like y equals f of x plus c. So that's you're adding a constant. Or it could look like this, y equals f of x minus c. All right, so if it's this one, if it's plus c, then you're shifting f of x up c units. So you're shifting f of x up c units. If you're subtracting from your function, if you're subtracting a number from your function, then you're shifting f of x down c units. Okay, so vertical shift up c units, vertical shift down c units. All right, so let's look at an example for that one. So let's suppose we look at this one. So for example, and let's suppose we had, I'm going to do the absolute value function. So let's suppose you want to graph f of x equal the absolute value of x plus 2. Let's say it was absolute value of x plus 2. All right, so a couple of things you got to remember. When in the worksheets and in my math lab, they're going to talk about the word basic function, or they could use parent function. Basic function or parent function. So that's the word basic right here, basic, B-A-S-I-C. So basic function or parent function. When they talk about basic function, in this particular case, the basic function is the absolute value of x. So in our cases, when we talk about these, your basic functions will be y equals absolute value of x, y equals x squared, y equal square root of x, and y equal x cubed. So those are the four that we're going to talk about. Those are called your basic functions. Those are called basic functions or parent functions. And in terms of why it's called parent functions, because from these parent functions, you can create other kinds of functions, like offspring or something. So other kind of functions. So you can add, you can move it up, move it down, move it left, move it right. You can stretch it, shrink it. Okay? So those are called your basic functions or parent functions. So when we look at this one, and I'm going to go ahead and write it here. So this will be f of x equal absolute value of x plus 2. All right, so here's how you're going to do this. So these are called transformations, and you have to show those transformations. So you're going to say this. Step one, you're going to graph the basic function. So graph basic function. That's your step one. And so you're going to write like this. You're going to say graph basic function. Remember, in this case, your basic function is the absolute value of x. You're going to say graph y equals absolute value of x. All right, so remember, use a t-table if you need to. If you don't know what these look like, which you should because there was a math lab lesson a couple of months ago or last month that dealt with 3 of those at least. And absolute value is one of them. But if you don't remember how to do it, use a t-table. So if x is 0, the absolute value of 0 is 0. All right, so I'm going to plot the point 0, 0. So look, so you're going to say this, plot the point 0, 0. So that's this. All right, then remember you got to choose some more numbers. You can't just choose 1 or 2. If x is 1, y equals the absolute value of 1, which is positive 1. So I'll plot the point 1, 1. So again, you keep plotting those points like this. If x is negative 1, choose some negative numbers. If x is, because you got to choose all kind of numbers that's in this domain. So if you choose negative 1, the absolute value of negative 1 is a positive 1. So I'm going to plot the point negative 1, 1. Okay, like that. And then if x is 2, the absolute value of 2 is a positive 2. And if x is negative 2, the absolute value of a negative 2 is also a positive 2. And so I'm going to plot those 2 points that we just found, 2, 2, and negative 2, 2. And notice that this graph, these points here will lie on the same ray, like this. All right, and then also on this side. And notice, I just want you to remember something we talked about last week. So this is an even function, right? So that function's even. It's symmetrical about the y-axis. So that's an even function, which you talked about last week. Okay. Now, so remember, this is right here. This is y equals absolute value of x. But remember, I'm trying to graph this, right? And you're supposed to use the idea of transformations. So you must show all the different transformations that's occurring. That's the idea with these lessons, with this topic. So this topic is not just for you to go here and then use a t-table. You got to use the idea of transformation. So you start with the basic function, which is this. That's step 1. And then step 2 will be this. Step 2 will be, remember this plus 2? So that's where you're going to shift the function up 2 units. So you're going to say vertically, shift. This function here, your basic function, the one you just got in that previous step, shift y equals absolute value of x up 2 units. Up 2 units. And so now what's happening, I want to show you. So let me go ahead and get this transparency. I'm going to put it over this. So there's my the basic functions. Now it says shift it up 2 units. I want to show you what's going to happen. Just focus on this vertex right here. The vertex, this point right here. So I'm going to shift the graph up 2 units. So notice 1, 2. All right. So that you see all these points here, all these points that's on the basic function have been shifted up 2. Okay. And basically what's happening is that the x coordinate stays the same. All you did was add 2 to the y value. All right, so you see this right here, the y value is 1, right here. 1 plus 2 is 3. Here, the y value is 2. 2 plus 2 is 4. See that? Here, the y value is 3. 3 plus 2 is 5. Here, the y value is 1. 1 plus 2 is 3. 2. 2 plus 2, I didn't align it very well, is 4, and so on. So that's shifting it up 2 units. So that's what that is. So basically you're going to do this. Watch. So you're going to say vertically shift the basic function up 2 units, and all you do, there's no t-table to do. Don't do a t-table. Okay, if you do a t-table, that means you're not using the idea that you're supposed to use in this lesson. The idea is this: you're shifting it up 2, right? You're shifting it up 2. So you take this point, move it up 2. Let me use a different color. Let me use this one. Shift it up 2. You take this point, shift it up 2. 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 Then use your ruler, make it look the same shape. Okay, it's got to look the same shape. So take your ruler, draw your line, and like this. I didn't do a very good job connecting the dots, the points, but that's okay for this. And then you have this, and this right here is this function right here. F of x equal absolute value of x plus 2. All right? And so that's what you're going to do in these lessons. In those 3 days, you're going to look at things like this. So I'm going to remind you what to do first. First thing you're always going to do is you're going to graph the basic function. Whenever you are told to use transformations, step 1 is to always graph the basic function or the parent function. And then step 2 is to use your either translation, vertical stretching, shrinking, or reflecting. And all you had in this case was a vertical shift because of that plus 2. There was nothing else you saw. My parent function and then plus 2, and that's it. So there's only, all you did was take the parent function, move it up 2 units. All right, so that's what that is. All right, let's look at another example. So let's suppose we had this. This will be example, so this was example 1 right here. Let's call this example 2. So example 2. So example 2, let's suppose we had this for example 2. All right, example 2. Let's suppose we had, I'm going to call it g of x this time. G of x is equal to the square root of x minus 4. G of x equals the square root of x minus 4. All right, now remember, the direction is going to say use transformations to graph this function. If it says that, then you have to show me the different transformations that occur to get to this point. All right, so remember, whenever you're told that, step number 1 is to always graph the parent function. And hopefully you can tell me in this case what you think the parent function is. So y equals, the parent function is the square root of x. That's your parent function. So square root of x. All right? And so now, for this one, to graph the parent function, if you want to use a t-table, if you can't remember what it looks like, that's fine. But that's the only time you will use a t-table, is for this. The rest, you're supposed to use the idea of moving things around, stretching, shrinking, and all that. All right, so let's use a t-table to help us to graph this. So remember, you're taking the square root, right? So you can only take the square root of a positive number or 0. So you will never use a negative number here. In the previous problem, notice I used some negative numbers because that was part of the domain for an absolute value function. But when you talk about square root, remember, the square root, you can only take the square root of a positive number or 0. So my domain, the domain is that x must be greater than or equal to 0. So you cannot use a negative number because the square root of negative 4, let's say, the square root of negative 4, see x is negative, that's undefined. That's not a real number, not a real number. All right, remember you get that imaginary number, that 2i? All right, so that's not a real number. So you cannot, when you graph the basic function here, the parent function for the square root of x, you got to use any number that's greater than or equal to 0. So let's use 0. So if x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. And you're going to notice I'm going to do this. I'm going to use, see, I'm dealing with the square root, right? So I'm going to sit, and I don't want to use my calculator. So I'm going to use some nice numbers for x. So I'm going to use 4 next, square root of 4. So I'm hoping you realize, hey, he's using 4 here because 4 is a perfect square. And the square root of 4 is just 2. So 4, 2. So if I continue that, then you will say, well, the next one will probably be the square root of 9. That's true. 9 is a perfect square. The square root of 9 is 3. All right. Oops, sorry, 3. All right, and then let's go ahead and graph these. I'm going to show you what's going to happen. So remember, step 1 is always graph the parent function. All right, so let's go ahead and do that. So I'm going to do that here. So let me get that pin. All right, so we have 0, 0, 1, 1, 4, 2, 9, 3. So 0, 0, 1, 1, 4, 2, 9, 3, and so on. But I ran out of room here, so I'm going to stop at 9. And then notice, be careful. Remember, it starts here. There's no arrow here. This is where it starts. So you're going to do this. You're going to draw a curve that looks like this with an arrow on this side. Start here, because remember, you can't use any negative numbers. So 0 is where you start, and that's a closed circle right here. So you start there, and then your domain goes all the way to infinity, from 0 to infinity. So notice the arrow. I want you to notice something, though. If I do it this way, that looks like part of a parabola, doesn't? So if I continue on, and you wouldn't, but if you were to draw this portion here, that would look like a parabola. So the square root function is part of it, or the part that you see is part of the shape of a parabola. So it looks like this. All right, so that's the square root function. So that's the first thing you did, was graph y equals, square root of, that's square root of x. All right. Okay, now, so that was step 1. But remember, I want to graph g of x, which is the parent function, subtract 4. Well, if you subtract 4 from the parent function, that means you're going to shift it down 4 units. So you're going to say step 2. So step 2 is now you're gonna vertically, vertically, so vertically shift the function you just did. You just graphed y equals the square root of x down 4 units. All right, so that's your step 2. So here's what it looks like. And I'm going to use a transparency to kind of tell you what's happening. So let me go back to this now. So I'm going to put this over this. So there's my square root function. And then remember, I want to graph this. All right, so I'm going to take my parent function, which is this. I'm going to shift it down. Why is it down? Because negative 4. If this was plus 4, you shift it up. But it's negative 4, you're going to shift it down. So notice what happens. So look, focus on this point right here, where the graph starts, right here. So I'm going down 4 units. 1. All right, and notice all of them went down 1 unit so far, right? All of them went down 1 unit. Now I'm going to go 2. 2 units so far. 3, 4. And this right here should be the final graph. Should be the graph of what you want. All right, so this is step 1. This is step 2, and that will be your answer. All right, so now what you can do is this. So you now know you're going to take the parent function and you're going to shift it down 4 units. So every point on the parent function, you're going to go down 4 units. 1, 2, 3, 4. 1, 2, 3, 4. Go here. 1, 2, 3, 4. And then the other one was right here. The other nice point was right here. So notice we did 4 points. Remember, 1, 2, 3, 4. So go down 4 here. 1, 2, 3, 4. And now draw your graph. It's got to be the same shape like this. So whenever you have a horizontal translation or a vertical translation, the shape looks exactly the same. The shape looks exactly the same. Okay? Whenever you do a horizontal or a vertical translation, the shape looks exactly the same. All right, so here is a parent function, and then you're going to say right here, you're going to say this is going to be g of x, which equals the square root of x minus 4. And that's all that is. So that's all vertical translation is. You're going to take the parent function, you're going to move it up or down. That's all it is. And I want you to notice all you're doing is just, in terms of, remember you shifted down, all you're doing is just, the x coordinate stays the same. All you're doing is subtracting, in this case, subtracting 4 from the y coordinate. So I want you to notice this. The y coordinate is 0 right here, right? 0 subtract 4 is negative 4. What's this y coordinate right here for this point? The y coordinate is 1. 1 subtract 4. 1 subtract 4 is a negative 3. Isn't that a negative 3 right here? What's this y coordinate right here? The y coordinate is 2. 2 subtract 4 is negative 2. So that new y coordinate, that transformed y coordinate is going to be, the point here will be 4, negative 2, and so on. That's all it is. All right, so that is, right now, that is, let me go ahead and remind you. So this is translation. So what we did so far is talk about vertical translation. So that's vertical translation. Vertical translation is the easiest for students. It is the easiest. Vertical translation is the easiest. You either go up or down. Horizontal translation is not as easy because students get confused with one part of it. So let's talk about horizontal translation. Horizontal translation. So this will be, let's see, let me write this as, let me write in black, horizontal. So this is horizontal translations. So horizontal translations. Okay. Now, we know that a vertical translation, we know that a vertical translation, remember vertical means up or down. We know that a vertical translation looks something like this. F of x equal a parent function minus 6. That's a horizontal, I'm sorry, that's a vertical translation. Your parent function, notice the subtract 6 is on the outside of the parent function. See, it's on the outside. So you take your parent function and then you go down. Okay, that's vertical. That's easy. But here's what horizontal looks like. Horizontal looks like this. And we're going to do an absolute value again. Horizontal, here's what a horizontal would look like. F of x equal absolute value of x plus 2. That's a horizontal translation. That's horizontal. You see that plus 2 is on the inside. Plus 2 is on the inside. This is vertical. Where's the plus 2? It's on the outside of the parent function. If it's on the outside, it's vertical. If it's on the inside, it's horizontal. Okay? It's horizontal. Now, here's where students mess up. Okay, so I'm going to go ahead and put this here. Here's where they mess up. So we're looking at this one, right? So whenever you see that, you know that's horizontal because the number is on the inside of the parent function. So we all know that the basic function looks like this. And we know that this is horizontal translation. With vertical, it is straightforward. Subtract 6, you go down 6. Add 2, you go up 2. Horizontal is not straightforward. Here's what students are going to do if you're not careful. They see that +2, and then they think, all right, it's horizontal, it's +2, so I'm going to go to the right 2. That's not true. You don't go to the right 2. It's counterintuitive. Counterintuitive. Think the opposite of what you see. Think the opposite of what you see. So the opposite of what I see is going to be a -2. So this would be shift y equal absolute value of x to the left 2 units. So counterintuitive. For horizontal translations, counterintuitive. Okay? So always think horizontal, think the opposite of what you see. All right. So basically, here's my parent function. I'm going to go to the left 2 units, 1, 2, and that will the part that you see here is actually the graph of this. All right, so horizontal, counterintuitive. Vertical, straightforward. -6, go down 6, +2, go up 2. Here, the absolute value of x +2, the number's on the inside. So instead of going to 2 to the right like you would 2 up here, you think counterintuitive, it's actually to the left. And here's the idea. I just want to emphasize this. So you see that vertex is here, right? So the vertex of the parent function is at the origin, okay? And so if you look at this right here, so the vertex at the origin. So the y value is 0. The y value is 0 right here, right? The y value is 0. When is this 0? This is 0 when x is -2. This is 0 when x is -2. So notice when x is -2, that y value is 0. So this is what it looks like right here. So that's why you're actually going to the left too, because you're trying to find out. See, you're going horizontal, so you still want that point to be on the x-axis as it is here. So you want that y value to be 0. And so the y value is 0 when x is -2. Makes sense because -2 plus 2 is 0. Absolute value is 0, 0. All right, so let's talk about how to do this on your on test 3 and also on your worksheets. So the directions will say, so let's write this example 1 for horizontal. So example 1, let's go ahead and graph f of x equal, let's do this one, absolute value of x plus 2. All right, so here's what you're going to say. Remember, as always, the first step you're going to do, step number 1, is to graph the parent function. Graph the parent function. We're dealing with absolute value, so my parent function is y equals absolute value of x. That's your parent function. And so we all know what the absolute value of x looks like. So the absolute value of x, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2, and so on. When x is -1, y is +1. When x is -2, y is +2. And then do the best you can. You use a ruler if you need to help you draw this more of a straight ray. So you get this. Okay. Now, notice what I'm doing. I am indicating what this is the graph of. This is the graph. This right here is the graph of my parent function, which is this. So you're going to say this is y equals absolute value of x. But remember, you want to use transformations. So you're going to graph, you want to graph this using transformations, So you're going to do one thing at a time. You're going to graph one thing at a time. And so the next thing you're going to do is think. All right, so this is a horizontal transformation. It's +2, meaning that I'm actually going to go to the left 2. Left 2. So you're going to take the graph you just did. You're going to take the parent function, and you're going to go to the left 2. 1, 2. So your final answer will be this graph that you see here. So I want you to notice something. Everything was shifted to the left 2, right? This point, go 1, 2. What? Now notice this point. Same thing here. You see this point here? You went 1, 2. This point here, 1. I didn't align it very well. Okay, this point here, 1, 2. So notice every point on the parent function, you went to the left 2. So 1, 2, 1, 2. Notice I'm taking this point, going to the left 2. 1, 2, 1, 2, 1, 2, 1, 2. And now take your ruler, like this, and then tell me that this right here, that you just did, is what I wanted to graph. So that is f of x equal absolute value of x plus 2. All right. So notice your parent function, and then since there was only one transformation you did, and that was moving it to the left 2, you only saw one other graph. So your parent function and then the graph you wanted eventually. All right, so that's horizontal. That's all that is. That's horizontal translation. All right, so let's see. All right, so let's look at this one. We're running out of time for this part, so let me go ahead and do this one. So let's suppose now. So we talked about vertical translations. We talked about horizontal. All right, so let me mention about horizontal again one more time. So horizontal. Oh, I forgot to mention this. I'm sorry. So this was step 1. Step 2, you're going to say this. Step 2, you're going to shift. You're going to write like this. You're going to shift horizontally. Shift y equal absolute value of x horizontally to the left 2 units. All right, and so that's what we did here. So here's your step 1. Here's your step 2. All right, and I got to see that. I have to see step 1, step 2 with this. Step 1, step 2. Okay. All right, a couple of things I got to mention about horizontal though. So whenever you see this, whenever you see y equal f of x plus c, that plus c means you're going to shift horizontally to the left. So remember that plus c, right? Plus 2, you go to the left, counterintuitive. Shift to the left, c units. If it's this, y equal f of x minus c, you're going to shift horizontally to the right c units. All right, so for example, let's just actually do this. Let's do example 2. Example 2. Suppose I wanted to graph suppose I want to graph this. G of x equal the square root. Let's do a square root. The square root of x minus 3. Square root of x minus 3. Okay? Square root of x minus 3. All right, so we did enough examples to where you can tell me what step 1 is. So step 1's this. Step 1, and remember it's going to say using transformations. If it says use transformations, you do those steps. Step 1, graph the parent function. Graph the parent function. And the parent function is the square root of x. So y equal square root of x. That's my parent function. All right, so that means this. That means you're going to remember your parent function. Remember that absolute value. I'm sorry, the square root. So 0, 0, 1, 1, 4, 2. The square root of 4 is 2. And the square root of 9 is 3. So remember, that's your parent function. Y equal, don't forget the arrow, y equal square root of x. Now, hopefully, you now know that if you take a transparency, or you don't need a transparency, just intuitive, you know what's going to happen. Minus 3, right? Counterintuitive. So instead of going to the, here's a transparency. So instead of going to the left, you can do what? Go to the right 3 units. So every point is shifted to the right 3 units. So that's what that says. So the next thing you're going to do is say this. Step 2, shift horizontally. Horizontally. And when I say shift horizontally, I mean this. Y equals square root of x. To the right. Counterintuitive. Don't say -3, go to the left. Counterintuitive. That's a horizontal translation. To the right, 3 units. And so now what you're going to do, once you do step 1, step 2, so there's your step 1. Now let's graph step 2. Step 2, move it to the right 3 unit every point. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay? The shape needs to be the same. All right? So the shape's the same. Whenever you do a horizontal or vertical translation, the shape is the same. See the shape? That shape looks exactly like this. It just moved over. All right, so that is horizontal. Okay, now, what I'm going to do now is the next part is reflection. That's easy for students. So let's talk about reflection. All right, so there's another transformation we're going to talk about is reflection. So there are two kinds of reflections that we can talk about. One is reflection about the x-axis. Reflection about the x-axis. The other one is a reflection about the y-axis. Most of the time, you're going to be dealing with the first one, reflection about the x-axis. All right, so let's talk about the first one for right now. So this is number 1, reflection about x-axis. All right. So what happens is this. I want to show you something. This right here is the graph of y equal x squared. There's your problem. You had one like this, I think, either on my math lab. I think the one in your test was an absolute value function, but this is a problem. This is x squared. So when you reflect this about the x-axis, see, here's your x-axis, right? So when you reflect something about the x-axis, I want you to notice what happens. I'm going to reflect it about the x-axis, and notice it looks like this. So instead of pointing up, when you reflect this about the x-axis, here's the x-axis, reflected about the x-axis, it now points down. Notice though, the vertex of this parabola, which is at the origin, stays at the origin, right? And then I want you to notice that when you reflect it about the x-axis, the x-coordinates stay the same. It's the y-coordinate that change opposites. +1, -1. I'm going to go ahead and plot that point. Then this one was +4, -4. This right here, let me move it down. This right here was, remember when x is 3? When x is 3, 3 squared is 9. So you see the y value 9? So that's a 0.39. When x is 9, when you reflect it, you get 3, -9 right here. And then the same thing over here, -1, +1, -2, -4, and then -3, -9. So what happens is that, and then remember the origin stayed where it was. So when you do this one, it looks like this. All right, it looks like this. All right, so here is y equal x squared. This right here, when I reflect it about the x-axis, I get this. Okay? Now let's talk about what the function looks like. All right, so when we talk about reflection by the x-axis, you now know what it looks like. Reflect something by the x-axis. When you reflect something about the x-axis, the x-coordinates stay the same. The y-coordinates were opposites. 1, -1. 4, -4. 9, -9. X-coordinates stay the same. X-coordinates stays the same. The y-coordinates were opposite. 1, -1. 4, -4. 9, -9. What does that is this. So when we're talking about reflection by the x-axis, it looks something like this. Y equal -f of x. That's what it is. So whenever you see a negative in front of the parent function, a negative in front of your function like this, that is a reflection about the x-axis. That's a reflection about the x-axis. That's what that is. All right, so let's look at this one. So let's go ahead and graph using transformations, All right, graph using transformations. F of x equal negative square root of x. Let's do that. So let's call this example 1 for reflection. Example 1 for reflection. All right, so example 1, graph this using transformation. All right, so remember step one is to graph the parent function. Graph the parent function. Okay, graph the parent function. All right, so remember, parent function is your square root, so that's y equal square root of x. You all know that looks like 0, 0, 1, 1, 4, 2. So you see those key points I'm doing? And then 9, 3. So those are the only parent function you're going to deal with is the 4 that I showed you earlier. And it looks like this. All right, now, all right, see this. All right, so now you're going to do this. So that's a parent function. Now you want to do the reflection. So you're going to say step 2, reflect what you just did, the parent function, y equals square root of x, about the x-axis. And that's all you say. That's all you say. Reflect the parent function about the x-axis. And when I do that, remember when we reflect about the x-axis, the point here that's at the origin stays at the origin. The point here that's at 1, 1, reflected by the x-axis becomes 1, negative 1. The y value changes. That's all it happens. The y value changes. 1, negative 1. What's this? 2. What does it become? So 4, 2 becomes 4, negative 2. Reflected about the x-axis. Notice this. The distance here to the x-axis is the same as from the x-axis to the reflection. Here, this distance is 3. Go down 3. 1, 2, 3. All right? That's all it is. And so the shape's the same. The shape is the same. It's just reflection about the x-axis. See that parabola looks like? Looks like a parabola, sideways parabola. So this is y equal square root of x, and this is your function. We called it f of x. So this is the function f of x equals negative square root of x. All right, and that's all you do. So that's all it is. So that's what transformations is. So we talked about vertical transformations, we talked about horizontal, we talked about reflection about the x-axis. There is something called reflection about the y-axis. All right, I'm not going to do that in this review because of the time we have left, but it is one of the lessons in the topics, either Monday, I think it's Tuesdays. It's in Tuesday's lesson. But I just want to tell you, on a test, I'm not going to ask about reflection about the y-axis. It will be a reflection about the x-axis. But on a worksheet on my math lab, you could be asked something about the reflection about the y-axis. But because of our time, you're going to have to look at this in one of the videos that's, I think it's on Tuesday, on Tuesday's lesson. Okay, now, here's the other thing I want to do though. So one of the other things we mentioned, let me find that page. One of the other things we mentioned is this. So we talked about translations. We talked about reflection. The only thing we did about reflection, though, was reflection about the x-axis. We didn't talk about reflection about the y-axis. What we're going to do now, though, is talk about stretching or shrinking. Another word for shrinking, you may see this word, compression. Stretching or shrinking, stretching or compression. Those are synonyms for each other. Okay? So let's talk about the stretching first. Okay. So listen to this carefully. So this is stretching. And by the way, when we talk about stretching, just want to say this, when we talk about stretching or shrinking, shrinking, stretching or shrinking. You can talk about this in terms of vertical, stretch or shrink, or you can talk about this in terms of horizontal, stretch or shrink. For test purposes, in here, we're gonna focus on this one only. Vertical, stretch, or shrink for a test only. Now in my math lab, they could ask something about horizontal, but for a test, we'll focus on the vertical. So let's talk about this with the 5 minutes we have left on this part. So we're going to talk about vertical, stretch, or shrink. Okay, listen carefully about what I'm about to say. All right. Okay. So here's what a vertical stretch or shrink will look like. You could see something like this. F of x, let me write it this way. Y equal 2 times x squared. Okay? Y equal 1/2 times x squared. So whenever you have a vertical stretch or shrink, you're going to see a number, your parent function. This is your parent function here. That's your parent function. The parent function will be multiplied by a number. So whenever the parent function is multiplied by a number other than 1, that's a vertical stretch or shrink. That's a vertical stretch or shrink. Okay? So let's talk about a vertical stretch or shrink. Okay, so let me go ahead just to kind of show you why it's called the way it is. So y equal x squared, let's graph the parent function first. So y equal x squared, I'm graphing y equal x squared first. So when x is 0, y is 0. When x is 1, 1 times 1 is 1. When x is 2, 2 times 2 is 4. When x is 3, 3 times 3 is 9. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. Negative 3 times negative 3 is 9. So you get a graph that looks like this. So there's your parabola right here. Okay? All right. What I want to do, though, is I want to graph y. So this right here is y equal x squared. What I want to do is graph y equal 2x squared. 2x squared. So that's what I'm going to graph now. Y equals 2x squared. All right. So basically, when you graph y equal 2x squared, notice that this is your parent function is being multiplied by 2. So I want to show you something. I'm going to use a t-table, although you won't on the transformation part. I just want to show you why it is the way it is. So if I use a t-table, and if x is 1, 1 times 1 is 1. 1 times 2 is 2. So I get the point 1, 2. So that's this. See that? Okay. When x is 2, 2 times 2 is 4. 4 times 2 is 8. So I get the point 2, 8, which is here. And I'm running out of room, so that's all I'm going to do right now. So I want you to notice something, though. You see, I'm going to take the parent function. I'm going to multiply by 2. So basically what's happening is that, see this y value right here? 1 times 2 is 2. What's this y value right here? 4. 4 times 2 is 2, so you get 8. So that's what's happening. So whenever you have a vertical stretch, the y coordinates are multiplied by this number. The y coordinates are multiplied by this number. Okay? So same thing here. 1 times 2 is 2. 4 times 2 is 8. So here's the graph of y equals 2x squared. Is this right here? All right, so that's the graph of y equals 2x squared. All right, so that's a vertical stretch. So you're taking this function, you're stretching it. You're pulling it up. Now a vertical shrink would look like this. So that's this one right here. So this is a vertical stretch. So vertical stretch is where this number right here, let's call it C. So vertical stretch is where C is greater than 1. So this number is greater than 1, then you have a vertical stretch. If this number is between 1 and 0, then you have a vertical shrink. This is the harder one for students. The vertical stretch or shrink is the harder one for students. So that's a vertical shrink. All right. So basically what happens is that when you have a vertical stretch, it pulls the graph of the parent function, pulls the graph of the parent function towards, so see what happened? That was a vertical stretch right here. So it takes the graph of the parent function and it pulls it towards the y-axis. So it takes the graph of the parent function and pulls it towards the y-axis. For a vertical shrink, what's going to happen is that it's going to move it this way. So it's going to pull it towards the x-axis. A vertical shrink moves it towards the x-axis. So vertical shrink pulls the graph of the parent function towards the x-axis. So vertical shrink pulls it towards the y-axis. Vertical stretch pulls it towards the y-axis. A vertical shrink pulls it towards the x-axis. All right. So let's look at an example of a vertical shrink. So let's do this one. All right. So let's look at this. So let me write this example. So let's suppose you want to graph y equal, let's do g of x. G of x equal 1/2 times the absolute value of x. So y equal 1/2 times the absolute value of x. All right, so listen carefully about this say, using transformations. Transformations. So listen carefully. Step 1. Step 1. Step 1 is to graph the parent function. Graph the parent function. So the parent function is the absolute value function. So that's y equal absolute value of x. All right, so let's go ahead and do that now. So we're going to graph it in a coordinate grid. So 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and so on. So it looks like this. Okay? So that is y equal absolute value of x. All right, now listen carefully about to say. Step 2. Step 2. So step 2, and you can write it in several different ways. Here's what some students will say. They will say, and you got to remember that this right here is a shrink, not a stress. So they would say shrink vertically by, all right, now you're multiplying, right? 1/2 times. So you're going to say stretch vertically by a factor of 1/2. That's one way you can say this. Stretch vertically by a factor of 1/2. Now here's what else I will accept. I will accept this. Step 2 will say multiply the y values of y equal absolute value of x, multiply the y values of y equal absolute value of x by 1/2. Those two mean the same thing. Whenever you multiply y value by 1/2, you're shrinking vertically. You're pulling the graph towards the x-axis. Remember what we talked about a while ago. Let me find it. We have a lot of pages here. Let me find what I wanted to. Okay, so this right here. So whenever you shrink vertically, you're pulling it towards the x-axis. Whenever you stretch vertically, that's where c is greater than 1. C here is between 0 and 1. So whenever you stretch vertically, you're pulling it towards the y-axis. So meaning this right here, the graph of this will be this way. You're going to stretch it. It's going to move towards the x-axis. So listen carefully. See this y value right here? What's that y value? That y value is 1. 1 times a half is a half. See that half right here? This y value right here is 2. 2 times a half is 1. So you get something that looks like this. Right here, 1 times a half is a half. 2 times a half is 1. So you get something that looks like this. So this right here is the graph of g of x, right here. So this is g of x equals 1/2 absolute value of x. That is not easy. It's not easy for some students, but the more you do, the more lessons you look at, you tend to understand it better. All right, and remember, so this is 1/2 x, right? So this right here would be y equals 2 absolute value of x. So 2 absolute value of x is where you take the y value of parent function, you multiply it by 2. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. 2 times 2 is 4. So that one looks like this. All right, so that is y equals 2 absolute value of x. So here's your parent function. Here's the graph being shrunk vertically, so it's moving towards the x-axis. Here's the graph being stretched vertically, so it's moving towards the y-axis. All right, now we have time for one problem, and I want to do this one. So let's do a problem where we put them all together like this. So let's go ahead and graph f of x equal, let's do 2 times the absolute value of x minus 3 plus, let's do 1. All right, now listen carefully. I'm about to tell you. There are a lot of things happening here. All right, the steps you do your transformation in, and you're gonna see this in the lessons. It talks about in the lessons, but the steps you're gonna do your transformation in will be this. The first thing you're gonna do is horizontal translation. Horizontal translation. Second thing you're going to do is stretch or shrink. Third thing you're going to do is reflection, if there is any. And you always do this last. This is always done last. Make sure this is always done last. Now I'm going to say this. You'll notice that if you change the order for the first three, you're going to get the same graph in the end. But the last must always be, the last thing you do must always be the vertical translation. Vertical translation must always be done last, because if it's not, you're actually graphing a different function. If vertical translation, remember the vertical translation is the number on the outside. If the vertical translation is not done last, you're actually graphing a different function than you want to. All right, so let's do this one. So step one, graph the parent function. And remember, we're dealing with absolute value, right? It's absolute value, so the parent function is absolute value of x. So here's what you're going to do. On your grid, you're going to graph the parent function. 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. Okay, that's your step one. So that is y equals absolute value of x. Step two, let's do the horizontal translation next. So remember, negative 3, do I take this, negative 3, horizontal, right or left? Do I take this and go to the right 3 or to the left 3? Intuitive, counterintuitive, thing, the opposite of what you see. So you're actually going to go to the right 3. So you're going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. So step 2 is you're going to shift y equal absolute value of x, it's right here, to the left 3, I'm sorry, to the right 3 units. So that's your step 2. So you're going to take this and shift it to the right 3 units. So now you get this. So now you have y equal absolute value of x minus 3. So that's what I'm about to graph. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, and then you draw the absolute value function. All right, now this right here, you got to label it. That is y equals absolute value of x minus 3. Okay? Now let's do the stretching. Always do the vertical last. Now let's do the stretching. Step 3, you're going to take the y value of this function, which is, remember, this is where you're at now. You're at this part right here. You went from here to here. Step 1, step 2. You're going to take these y values. Remember, step 2, this part here where you're multiplying by 2, you're going to multiply the y value by 2. So you're going to take the y value of y equal absolute value of x minus 3 and multiply by 2. So here's what's happening. What's this y value right here? Well, that y value right here is 0. What's 0 times 2? 0. What's this y value right here? That y value is 1, right? What's 1 times 2? 2. What's this y value right here? That y value is 3. The y value is 2. 2 times 2 is 4. I think I put in the wrong place. Let's do this again. This y value right here is 0. 0 times 0 is 0. This y value right here is 1. 1 times 2 is 2. There's a 2 right here. Sorry. So take this off. So this y value is 2. 2 times 2 is 4. So I get this so far. Now on this side, 1 times 2 is 2. This y value is 2. 2 times 2 is 4. All right, so you get this. So you have a lot of things going on here. So this was step 1. This is step 2. You see, now you're taking step 2 and you're shifting it vertically up, right? All right, so that is right here, y equal to absolute value of x minus 3. And then finally, look, you're going to shift it up 1 unit. So step 4. Oh, and by the way, you could also say this. You could also say stretch y equal absolute value of x minus 3 vertically by a factor of 2. Means the same thing. Those two mean the same thing. Step 4. Step 4 is where you take that third graph. Graph 1, graph 2, graph 3. Step 1, step 2, step 3. And you move it up 1 unit. You shift it up 1 unit. See that plus 1 on the outside? That's a vertical shift up 1 unit. So you're going to say this. So shift the third graph, and here's the third graph right here. So shift y equals 2, absolute value of x minus 3, up 1 unit. When you do that, when you shift this up 1 unit, you now have this. You now have the graph of y equal 2, absolute value of x minus 3, plus 1, which is what you wanted. So here's what you're going to do. Every point, remember when you shift it up, make sure you're using the third graph now. Every point goes up 1 unit. This point, up 1 unit. This point, up 1 unit. This point, up 1 unit. So now this side looks like this. This point, up 1 unit. This point, up 1 unit. So now this looks like this. Okay? and it looks messy. This right here is the final function f of x equal 2 out to the value of x minus 3 plus 1. So the idea of transformations, and we looked at most of the transformations that you will ever encounter in this course, but we looked at the ones that were going to be on a test. It can get messy. See how messy it becomes? So you may want to use different colors. I didn't have different colors here. You may want to do this graph a certain color, the second graph a certain color, and so on. Some students use different colors. It helps if you use the different, take a marker and use different colors to do this. But this is what you have to say. Step 1, graph the parent function. Step 2 was the horizontal shifting. Step 3 was the stretch in this case. And step 4 was the vertical shifting. All right, and that's it. So it is a lot that we covered. So when you go back to the agenda, this is actually covered in 3 days. There's something for Monday, something for Tuesday, something for Wednesday. What I did here was kind of summarize all those 3 days for the most part, for most of the stuff that's in there in this 1 hour. Okay, so let me go ahead and end this.